Okay, so right here we've got a systems of equations that we're trying to solve. Whenever we deal with the systems of equations problem, there's always two possible ways of doing it. The first possible way of doing this, and I don't know if this is the better way, is substitution. If we would do substitution, we would solve one equation for one of the variables. Let's say we solve for x, then substitute that value into the other to solve for the other variable. Now, that's an option. I don't particularly like doing that, especially in this situation. And the reason for that is the other way of doing this is with elimination. And elimination, I think, tends to be easier. So I'm going to solve this with elimination, and then at the very end, I will resolve it for substitution because I think elimination is the best way to go here. So I'm just going to take this first expression and I'm going to rewrite it so it's in standard form. What that means is I'm just going to rewrite this as 6x plus 9y equals negative 9. Okay, all I've done is I've just moved this 9 over to the other side. This is just a nicer way of working with it. We tend to work in standard form. Now, that second one, ooh boy, that is not a friendly equation because it has fractions. And what everyone knows is fractions suck. But before I do anything, I am going to rearrange this as well so that it is again in standard form. And all I've done is I've brought the 1/3 y over to the other side by subtracting it. Okay, now here is my number one suggestion for you whenever you get a problem that looks anything like this. Let's get rid of the fraction. The easiest way of getting rid of this fraction is to multiply by the highest common multiple, or lowest common multiple. If I multiply by 9, what that's going to do is it's going to make this fraction is going to go to -2, whereas this fraction is going to be 9 times 1/3, which is just 3, but in this case. So what I would end up with after I've multiplied by -9, I get -2x minus 3y equals -9. Okay? And just by doing this very quickly, if I bring those values right there, and then all I'm going to do at the end here is I'm going to finish this by just adding these two together. And in order to do that, when I add these two together, what I would get would be, well, first off, sorry, I can't just simply add them together. I first have to take this one, and I'm trying to cancel out one of these values. Doesn't matter which one I cancel out. Let's say if I multiplied this by 3, then again, I'm just going to move this out of my way so I can. If I multiply that by 3, I would end up with -6x plus 9y. Sorry, that's minus 9y. Minus 9y is the same as -18. Now, I can bring this back in, and I'm just going to add the two together and see what happens. Um, and I think you're going to notice that something weird is going to happen here. What's going to happen is I get negative 27, and then that's the same as 0y and 0x. Oh, good God. So what this means when we have a situation like this is these two lines are lying on top of each other. They are the exact same lines. So because these are the same, there would be infinitely many solutions. Now, this means that that first line, just so we understand, that first line might look something like that. And the second line actually lays right on top of the first line. It's just, they're the same line. Um, that's a little bit of a tricky problem. In general, on the test that you're going to take, the solutions will be an exact value. I apologize for that on this, but that's all that's happening there. Going through that process is important. But I think just being able to do the basics, you'll be golden. All right?